Hey there. In this video, we are going to find the determinant of a 4x4 matrix. Now, we have nice quick tricks and formulas for 2x2s and 3x3s, but when you get to a larger matrix like this, we're going to have to use cofactor expansion to find the determinant. Now, this is the same method I'm going to test you on, so it's good to get a demonstration of it. With this method, you're going to pick a row of the matrix. Usually you pick the one with the most zeros in it. I'm going to pick a less optimal one just so we get a little bit more practice with cofactor expansion. But for instance, this one, the second row is 0, -1, 0, 0. And so that'd probably be my first choice. It's going to be the most efficient way to find the determinant of this matrix. But I'm going to go with the top row, which just is 2, 0, 0, -3. So we can just get a little bit more practice with how this works and see it without getting too many zeros in it. Okay, so the determinant of D, since I picked the first row, I'm going to be crossing that row out in this formula that I'm going to implement. And then I'm going to take turns crossing out each column. And all the numbers that aren't crossed out are going to form 3x3 matrices that I'm going to have to find the determinants of. Right, so keep that row crossed out. I'm going to start with the first row and I'll cross out that one as well. And so you can see I get this 3x3 matrix here. I'm going to rewrite it over here with the bars to signify it's a determinant. And I'm going to multiply by the number that got crossed out twice. And for the first one, it's going to be positive. The sign is going to alternate with all the terms. So the next one's going to be negative, and then positive, and then negative, since we're going to have to do this 4 times for 4 columns. Okay, so that's the first one. Now I'm going to take and cross out the second column. And so that's going to be a minus. And this one's actually going to get multiplied by 0. I'm going to go ahead and write it out just so you can see each of these. But this second one, I'm not even going to have to find this determinant, which is why we like having rows with a lot of zeros in them. So the matrix that's formed, or submatrix, it has all zeros in the top row. And then 7, 3, 5, -6, 2, 4. Okay, so that's the second one. The next one's going to be positive. And so now I'm going to cross out the third column and I get another 0. So again, this is one I'm not going to have to calculate the determinant for. So far, it's just the first one. And the submatrix is 0, -1, 0, 7, 4, 5, -6, 2, 4. So just the numbers that haven't been crossed out. And one more column to go. So cross out the last column. And we went plus, minus, plus. So this one's going to be minus again. And -3 is the number that was crossed out twice. And then the leftover numbers form the matrix 0, -1, 0, 7, 4, 3, -6, 2, 2. Oop. And make sure you're using bars because these are determinants we're finding, not just a matrix there. Okay, so that one is 0. That one is 0 just because of the coefficients. And I'm going to have to find the determinant for these other ones. And so it might be something you want to do off to the side if you want to use the trick. You could do another cofactor expansion on each one of these. For 3x3, like to do the trick where you replicate the first 2 columns to the right and multiply the diagonals. So I'm going to do that off to the side here so I have some space. So I have -1, 0, 0, 4, 3, 5, and 2, 2, 4 for the rows. And so those first 2 columns I will replicate to the side, and now I'll multiply my diagonals. So I've got 3 diagonals going down to the right. And there's already a lot of calculations here, so I'm going to do some of this, try and do it quickly. So that's going to be -12, and then zeros, and then minus. And now I'm doing the diagonals going the other direction. So that's going to be another 0, and 2 times 5 times -1 is -10, and another 0. So it looks like I'm going to have negative 12 plus 10 gives me a negative 2. So I have 2 times negative 2. When I go back up to my main diagonal. And now just the fourth matrix I have to do. So that's going to be a plus 3 times whatever I get for this determinant. So let's write this one. I've got 0, negative 1, 0, 7, 4, 3, and negative 6, 2, 2 in the matrix. So I'll replicate the first 2 columns so that I get my diagonals. Okay, so I'm not going to cross out the diagonals this time just so you can still see everything easily. But it looks like I'm going to get a 0. 1 times negative 1 times 3 times negative 6 is going to be 18. And I get a 0 for the third diagonal, minus. And going up to the right, I get a 0, another 0, and then 2 times 7 times negative 1. So that's going to be negative 14. So 18 plus 14, that's going to be 32. Okay, so I take that up here. So my determinant is going to be whatever I get from 2 times negative 2 plus 3 times 32, which if you plug that all into your calculator, you get 92 for the determinant here. So that's how you use cofactor expansion. And because I did not get 0, I can say that this matrix D is non-singular. It is going to have a inverse matrix.